The universe is vast, mysterious, and packed with secrets that even the brightest minds are still working to understand. In today's video, I've handpicked 10 mind-bending facts that will change the way you think about space. I'll keep things straightforward and to the point. No unnecessary talk, just pure information that's easy to understand and packed with value. Stick around until the end, because the third and the last fact is my favorite, and it might just leave you questioning everything. Let's jump right in. All right, here is our first fact. Is the universe infinite, or does it have an edge? What this means is, imagine you just kept flying in one direction. Would you hit a wall, or would you drift forever? Scientists have explored this for years, and there are three main theories on what the structure of the universe could be. Let's break each one down and see how true, or speculative, it might be. The first theory says, the universe is endless, stretching forever in all directions. No matter how far you go, there's always more space ahead. This theory is plausible but unproven. Our telescopes can only detect the observable universe, about 93 billion light years across. But just because we can't see beyond it, doesn't mean there's nothing there. Some cosmologists argue that if the universe is infinite, there are countless regions beyond our reach that we'll never see. The cosmic inflation model suggests space expanded extremely rapidly after the Big Bang, making it likely that the universe is much larger than what we observe. Since we can't observe beyond the visible limit, proving or disproving an infinite universe is nearly impossible. It remains a theoretical possibility but lacks direct evidence. The second theory says, the universe might be finite but curved, like the surface of a sphere. Traveling far enough in one direction would eventually bring you back to your starting point. This idea aligns with Einstein's general relativity, which allows for curved space-time. Some scientists believe space could curve onto itself, forming a closed-loop structure. Certain patterns in the cosmic microwave background radiation could hint at a closed-loop universe, but the evidence isn't strong enough to confirm this theory. The interesting question lies here is if the universe were looping, we should see repeated patterns in distant galaxies, like reflections or duplicates of our own galaxy. So far, we haven't detected anything like that, making this theory speculative but intriguing. The third theory suggests the universe is like a bubble that keeps expanding in all directions. The edge isn't a wall, but the limit of what we can observe, beyond which space expands faster than light can travel. This theory is the most widely accepted in modern cosmology. It aligns with the idea of cosmic inflation and explains why galaxies appear to be moving away from us in all directions. Observations of the cosmic redshift, where light from distant galaxies shifts to the red end of the spectrum, prove that the universe is expanding. The notion of dark energy also supports the idea that the expansion is accelerating. Even though this theory fits current observations, it raises new questions, like what lies beyond the bubble, or if there are other universes beyond our own. If you think this was exciting, wait until you hear what's coming next, because the next facts will blow your mind even more. And hey, if you're enjoying this journey through the universe, make sure to like the video and hit subscribe. Trust me, you don't want to miss what's coming next. Now let's explore our second fact. What holds the universe together? Dark matter and dark energy. With galaxies spinning at breakneck speeds and stars hurtling through space, why doesn't everything just fall apart? Turns out the answer lies in two of the universe's biggest mysteries, dark matter and dark energy. First, let's talk about dark matter, the invisible glue. Dark matter is this mysterious stuff that doesn't emit light or energy, so we can't see it or touch it. It's completely invisible to us. But here's what it does. It acts like a cosmic glue that holds galaxies together. Without it, stars would spin right off into space. In fact, scientists know dark matter exists because stars on the outer edges of galaxies move way faster than they should. That means there has to be something adding extra gravity, even though we still have no idea what dark matter actually is. Now, dark energy? That's a whole different beast. If dark matter pulls things together, dark energy pushes things apart. It's what's driving the universe to expand faster and faster every second. Think about it. Galaxies are not just drifting away from each other. They're speeding up as they go. And this expansion is caused by something we can't see or measure. Scientists believe dark energy makes up almost 70% of the universe. But just like with dark matter, we have no idea what it really is. It could be some strange property of space itself, or something else entirely. So here's the big picture. Dark matter pulls everything together while dark energy drives it all apart. And the craziest part? These two forces make up 95% of the universe, but we still don't know what they actually are. This is a very exciting topic and we can talk about it for hours, but for this video, I am not going deeper into it. Do let me know in the comments if you want a separate detailed video on dark matter and dark energy. Now let's jump into fact number 3. This fact is one very close to my heart, and I am sure many of you are probably waiting for this. What is black holes? Is it a portals or cosmic monsters? Black holes, they're one of the most mysterious and terrifying objects in space. But here's the big question. Are they just destructive monsters? Or could they be something more? Like portals to other parts of the universe? Let's have a look at what happens inside a black hole. When a massive star collapses, it creates a black hole, a place where gravity is so intense that not even light can escape. But the strange part? According to physics, time and space get twisted inside a black hole, making it one of the most mysterious places in the universe. There are several arguable theories out there about black holes. I will talk about 2 very exciting theories among them for now. Theory 1, black holes are cosmic destroyers. The most popular theory? Black holes are pure destruction. Anything that gets too close is stretched, crushed, and swallowed into what's called the singularity, a point of infinite density where the laws of physics completely break down. The next theory is black holes as portals or wormholes. Not all scientists think black holes are just monsters. Some believe they could act as wormholes, portals that connect 2 distant parts of space. If true, you could theoretically enter a black hole and pop out somewhere else in the universe, or maybe even in another dimension. Sounds cool, right? But here's the catch. We have no way of knowing what would really happen if something or someone fell into one, at least not yet. The way we are advancing in space science, I am very hopeful we will learn more about these very soon. So, black holes might be cosmic trash compactors, or they could be intergalactic highways waiting to be discovered. Either way, they are one of the most mysterious things in existence, and we're only beginning to understand them. Black holes are the most fascinating objects in the universe, and it's hard to stop talking about them. But the next fact is in tight competition with this one because it has a very special relationship with black holes. The fact number 4, time moves differently near black holes. Did you see what I did? I still couldn't stop talking about black holes. But this is even more interesting, so much that it can stop time around you. All right, here it is. Did you know that time flows differently depending on where you are in the universe? This is especially true near black holes, where time slows down to an almost standstill. Let's break this down. The idea is called time dilation, and it comes from Einstein's theory of relativity. The stronger the gravity, the slower time moves. And since black holes have the strongest gravity in the universe, time around them practically grinds to a halt. Imagine floating just outside a black hole. To you, everything would seem normal. But if someone watched you from far away, they'd see you moving in slow motion. A few minutes for you near the black hole could mean years or centuries passing for someone on Earth. This brings us the most debated question in the history of humanity. Can we do time travel using a black hole? In theory, if you could orbit just outside a black hole without falling in, you'd experience a kind of time travel, moving forward in time much faster than everyone else. But of course, the challenge is not getting sucked into the black hole's event horizon, the point of no return. So, near a black hole, time becomes more of a suggestion than a rule. For you, time might feel normal, but for the rest of the universe, it's fast-forwarding into the future. Crazy, right? And that's just one way space messes with time. If you're enjoying this journey till now, I really hope you are liking this. Now the next fact is even stranger. Have you ever heard of rogue planets, worlds without a star? That's our fact 5. Not every planet has a star to orbit. In fact, there are billions of planets floating through space all alone, without any sun, any light, or any warmth. They're called rogue planets. Let's explore how they exist and what makes them so fascinating. Some of these planets probably formed like normal planets, orbiting a star in the early stages of their life. But then, something went wrong. Maybe a massive collision or gravitational disturbance, and they were kicked out of their solar systems. Now, they're drifting alone through space. The big question is, how can these planets exist without sunlight? Well, most of them are thought to be ice cold and lifeless. But here's the crazy part. Some rogue planets might have their own heat sources deep beneath the surface, like volcanic activity or radioactive decay. If that's true, it opens the door to a wild idea. Could life exist on one of these dark, wandering worlds? Scientists have found strong evidence that rogue planets exist. In fact, there could be billions of them in just our galaxy. In 2021, astronomers discovered a batch of about 70 rogue planets floating through the Milky Way. But they're incredibly hard to study since they don't emit any light, making them nearly invisible to telescopes. So imagine an entire planet drifting through the darkness, completely alone. It's one of the strangest ideas in astronomy, and we've only just begun to understand it. Our next fact is a bit different. It's mysterious, strange, and just a little spooky. Right now, as we speak, our entire galaxy is being pulled towards something enormous. Welcome to our fact number 6. This is something we can't see, something we can't fully understand. Scientists call it the Great Attractor, and it's one of the biggest unsolved mysteries of the universe. The Great Attractor is a massive gravitational force, about 150 million light-years away. Think of it as a giant cosmic magnet that's pulling not just the Milky Way, but thousands of galaxies toward it at over 1 million miles per hour. Here's the strange part. It's hidden in a part of the sky called the zone of avoidance, blocked by dust and stars from our galaxy. Even with the best telescopes, we can't get a clear picture of what's out there. Some think it's a supercluster of galaxies, an enormous collection of matter we haven't fully mapped yet. Others believe it could be dark matter, or even something completely unknown, something that defies the laws of physics as we know them. So right now, everything in our galaxy is racing toward the Great Attractor, and we still have no idea what's waiting for us there. So far, we talked about a lot of dark facts. Now let's talk about a little brighter fact. Let's talk about something small, yet unbelievably powerful. Our next fact is about neutron stars, the densest objects in the universe, so extreme that a spoonful of their material would weigh more than Mount Everest. A neutron star forms when a massive star runs out of fuel and explodes in a supernova. The core left behind gets squeezed by gravity so tightly that protons and electrons merge into neutrons, creating a star made almost entirely of neutrons. Let's put it this way. If you could somehow scoop a teaspoon of neutron star material, it would weigh about 1 billion tons. That's like fitting an entire mountain inside your pocket. Neutron stars are so dense that their gravity bends light around them and warps space and time. These stars are incredibly strange. They're only about 12 miles wide, but they spin faster than a blender on turbo, sometimes completing 700 rotations per second. They also release powerful radiation beams, and when those beams hit Earth, we see them as pulsars, flashing lights in space. Neutron stars are well studied, and their properties fit within Einstein's theory of relativity. However, scientists still don't fully understand what happens inside one. At those extreme densities, the laws of physics begin to break down. Some researchers even speculate that the core of a neutron star could be made of exotic matter we've never seen before. Neutron stars are like cosmic laboratories, testing the limits of physics in ways we can't replicate on Earth. And trust me, the next fact takes us even further into the unknown. If you're enjoying this journey, make sure to like and subscribe. There's still more to explore. Next, let's talk about something really unexpected. Where do you think the coldest place in the universe is? Maybe in the deepest parts of space, far from any star or galaxy. Well, you might be surprised. It's actually inside a strange cloud of gas and dust called the Boomerang Nebula. And the temperature there? It's colder than the empty vacuum of space itself. Let's break this down. The Boomerang Nebula is a cloud of gas located about 5,000 light-years away in the constellation Centaurus. What makes it special is that it holds the record for the coldest known place in the universe. The temperature inside the nebula is a mind-numbing minus 457 degrees Fahrenheit, just 1 degree above absolute zero. Even the cosmic background radiation which fills empty space is warmer than this. Scientists believe the Boomerang Nebula became this cold because of an extremely rare event. A dying star at the center of the nebula is shedding its outer layers at incredible speeds, expanding the gas so rapidly that it cools down faster than the surrounding environment, similar to how expanding gas cools in your fridge or air conditioner. We know this cold spot exists because astronomers have measured the temperature using radio and infrared telescopes. But here's the crazy part. We still don't fully understand the exact process that creates such extreme cold. This makes the Boomerang Nebula a fascinating object that continues to challenge our understanding of how stars evolve. So the coldest place in the universe isn't some distant void. It's inside a nebula created by the death throes of a star. And the best part? There are still countless mysteries waiting to be uncovered. If you thought this was fascinating, wait until the next fact. It's even more mind-bending. All right, this next fact might just leave you questioning everything. What if I told you that everything you see, hear, and feel, our entire universe, might actually be a hologram? I know it sounds like science fiction, but this is a real theory that's been gaining traction among physicists. Let's dive in. The holographic principle suggests that the entire three-dimensional universe we live in could be the projection of information stored on a two-dimensional surface. In other words, much like a hologram on a credit card, everything we experience might just be a projection of something that exists on the edge of the universe. This idea came from the study of black holes. Physicists discovered that the amount of information inside a black hole depends not on its volume, but on the surface area of its boundary. This led them to wonder, what if the same principle applies to the entire universe? What if everything we see inside the universe is just the result of information stored on a distant surface, far beyond our reach? The holographic principle isn't just wild speculation, it's supported by certain findings in quantum mechanics and string theory. Some physicists think it might help explain the strange behavior of particles at the quantum level. But since we don't yet have any way to directly test this idea, it remains one of the most intriguing and speculative theories in modern physics. So, if this theory turns out to be true, everything we know might just be an illusion, a projection on the surface of the universe. Mind-bending, right? But it doesn't stop there. The next fact takes us even deeper into the strange world of physics. The final fact is coming up next. And now we've reached our final fact. How will the universe end? Will there be one final explosive event, or will everything just fade away into silence? The leading theory is called the Big Freeze, and it suggests that the universe might die, not with a bang, but with eternal darkness. The Big Freeze, also called the heat death of the universe, suggests that the universe will keep expanding forever, but as galaxies drift farther and farther apart, stars will eventually burn out, leaving nothing but cold, dead remnants. First, all the stars will exhaust their fuel. No more light, no more heat. Then black holes will slowly evaporate over trillions of years. Eventually, even the smallest particles will break apart, leaving the universe as a vast, empty void, a place where nothing happens and time has no meaning. The Big Freeze is currently the most accepted theory among scientists because it fits with what we know about the universe's expansion and dark energy. Unless something changes, the universe seems destined to grow colder and darker until there is nothing left. So after all the explosions, collisions, and cosmic wonders, the universe might just fade away quietly into the dark. But don't let that scare you. There's still so much left to discover in the meantime, and that's the end of our cosmic journey, for now. I hope you enjoyed this dive into the wonders and mysteries of the universe. If you did, do share your views in the comment section and make sure to like this video, subscribe, and stay curious. There's always more out there waiting to be uncovered.